Hello everyone, I hope you are doing well. So in this video, we are going to discuss the first 4 problems of Codeforces Round 892, which was written for Division 2. So today's contest was a total roller coaster ride for me, and I believe the first 3 problems are purely brute force. I spent a lot of time on problem C, and after taking one wrong summation, I literally solved problem D in just 15 minutes. You can check the difference in time between my first wrong answer on problem C and my pretest passed on problem D. So that was just like 15 minutes, and after solving problem D, I came back to problem C and I just somehow managed to solve it. So I believe the contest for the first 3 problems was a bit heavier on the brute force side, which I believe should not be the case for problem C at least. So anyways, let us start the discussion with problem A. So this particular problem says that we have been given an array of length n. Now we have to divide this particular array into 2 different arrays B and C, such that each of the arrays B and C has at least one element, and for each element in the array B there should not be any divisors of that particular element in the array C, right? So you can also say it the other way around. For each element in array C there should not exist a multiple of that particular element in the array B, right? Both of them are the same things, and this problem is purely brute force. You can solve it by brute force. I believe that my solution might be a little bit complex in terms of writing, but the overall idea is very simple. So let me just also explain you with the help of one example. So let's say that we have this particular sample test case with us. Now they are saying that we have these 5 elements in the initial array, and we have to create 2 arrays B and C. So for example, if I try to put these elements 1, 3 and 5 and then 2 and 4 here, you will see that there is no multiple of 2 that is present in the array B, and there is no multiple of 4 that is present in the array B. So this is a valid configuration, right? So now, since the total number of elements are only up to 100, what we can try to do is we can just try to brute force through all the values which can be present in my array C. Right. So let's say 1 is present in my array C. So I know that all the multiples of 1 should be present with C and should not be present in the array B. Right. So let's say if I am trying to take 1 in the array C, then all the elements that are multiples of 1 will be present in the array C as well. So in this case, you will see that all the elements will be in array C and there will be no elements left in array B. So the size of array B will be 0, which is not a valid case, and we cannot take 2 arrays B and C like this. Now for example, if I want to take 2 in the array C, so let's say I have 2 here, right? So what I would do is I would take all the multiples of 2 in the array C as well, and for the array B I would put all the remaining elements, that is 1 and then 3 and then 5, right? Now let us try to take the element 3 in array C. So if I take 3 in array C, I will take all the multiples of 3 in the array C as well. Since there are no multiples of 3 in the initial array, so it will be only one element here. Now for the array B, all the remaining elements 1, 2, 4 and 5 will be there, right? So this is also valid configuration and you can print any of them. So this is the whole idea behind the problem. What you have to do is you can take any one element, take all of its multiples together in the array C, and if there exists at least one remaining element, you can put it in array B and that will be a valid configuration, right? So let me just directly show you my code now. So you see what I have done is I've created a vector v of size n and I've taken input in the vector. Now I'm just traversing through all the values and I'm creating another vector t. So this vector t is actually going to act as my array C, right? So all the elements that are multiple of my element at index I, I'm just going to push back those elements in the t vector, right? Now if the size of the vector t is less than n, that means not all the elements are now present in the array T and there will be at least one element left for the another array, right? So I can just print the size of both of the arrays, right? Now what I can do is I can just try to go through all the values for all the indexes, and you can see I'm just storing the index of those places, not the values itself. So if that particular index is not present in my vector T, right, I can print it in the first vector. So there are actually arrays B and C. So for now just assume that this vector t that I have created here is acting as the array C. So for all the indexes that are not present in my array C, I am just going to print them in my array B, right? So this is doing binary search. This will tell me whether it is present or not, and if it is not present, I am just going to print it for the first vector. and for the remaining values I can print it for the second vector, right? And after if I have printed one answer, I can just return from here, and if I have found none of the answers, I can print -1 at the end, right? So I was talking about this part, that my implementation here looks a little bit complex, but it is not very difficult. What I'm trying to do is I'm trying to take all the elements in a single vector, and all the elements that are not present in that vector, I'm just trying to push those elements into the other vector, right? So this is how you can solve this problem. Now let us have a look at the second problem. So this problem was again a brute force problem. Now they say that we have been given certain arrays, right? So let's say the total number of arrays in the first sample test case is 2, right? So for each array we will be given a length of the array. So what we have to do is we have to take the minimum values of all the arrays and find the summation of all those values. Now we are allowed to perform some special operations. What are those possible operations? We can move at most 1, possibly 0 integers from each array to another array. So what I can try to do is I can take one element from my current array and take out of it and put it into some other array, right? So I can take out, listen to this very carefully, I can take out at most one element, but I can put multiple elements in any of the arrays, right? So this is very important for this particular problem. Now with the help of this operation, I want to maximize this value, that is also called the beauty of the arrays. So let me just consider a sample test case, and then you'll be able to understand this in a much better way. So this is the sample test case that we have. So what they are saying is we initially have 3 arrays. The size of the first array is 4. So let me just write it in sorted order. So it is going to be like this: 1 0 0 7. The size of the second array is 3, and if I write it in sorted order, it will be like this. The third array is this: 2 and 9. Right, so this is the size, and after it is the array itself. Now I believe that you must have understood what they are trying to define as the beauty of the system. The beauty is the summation of the minimum values among all of these arrays, right? So I can consider all of them and take the minimum of them and then sum all of it. So in the current state, the beauty will be 5 plus 6 plus 2, right, which is equals to 13. Now I can perform certain operations. What are those operations? From each of the arrays, I can remove at most one element and put it into some other array, right? So any array can give at most one element, but any array can receive multiple elements, right? So for example, I can take this 5 from here and I can take this 6 from here and I can put them both into this particular array and append it at the end, right? So I can do this particular operation. Now I have to perform these operations in such a way such that the value of the beauty is maximized. Now let us try to find out what will be the change in the values if I try to remove some element from any of the arrays, right? So if you want to change the value of this particular array, very obviously you would want to remove the minimum element, right? Because if I remove any other element, the value contributed by this particular array is not going to change, right? So definitely I am going to remove 5. If I am going to remove 5, then how will my answer improve? The answer will improve by 7 minus 5, that is 2 units, right? Because instead of 5, now this array is going to contribute 7, right? So this is the new contribution that will be made by my array if I remove the smallest element from this particular array, right? Now I can calculate the contribution of all the elements in a similar manner, right? So the contribution that this array can make is 2, the contribution that this array can make is 2 as again, and the contribution that this particular array can make is 7, right? Now I don't have to form any greedy solution. What I can try to do is I can just brute force through all the values, right? So if all of the arrays are giving, there will be at least one array which must be receiving those values. So let us assume that there is only going to be one array which is going to receive all the values and it is not going to give any value to anyone. So in that particular case, we can brute force through all the arrays to find out which one of them will become the receiving array. How do we find out the best answer? What we can try to do is, first of all, we can initialize our answer with the summation of all the minimum values. So in this case, it is going to be 5 plus 6 plus 2. So this is 13. Now what I can try to do is, I can just try to find out what will be the contribution made by all the arrays if they are the giving arrays. So it will be 2 plus 2 plus 7, right? So it is going to be 22. Now I know that all of them were not giving arrays, at least one of them was the receiving array, right? So let's say this one was the receiving array, right? If this was the receiving array, what will happen? The very first thing that I would want to do is remove the contribution made by giving the element by this particular array, right? So I want to remove this particular contribution. So let's say that inc was denoting increment in the value if this array gives some value, right? So I have to remove inc of 0. Now if it is receiving the smallest value from all the other arrays, that is 6 from here and then 2 from here, then it means the final array is going to look something like this: 2 5 6 7 1 0 0 1 and 1 0 0 7. Now this is also the difference that is being created by adding all the elements to this particular array. So first of all, what happened? I removed the contribution made by this 7, right? Because now this array is not going to give anything, it is going to receive something, right? So first of all, I neutralize this particular contribution, right? Now I see that if it is receiving the values from all the other arrays, it is also going to receive the smallest value among all the other values. So that in this case is going to be 2. So if it is going to receive 2, then I again have to remove the contribution made by 5 and add the contribution made by 2. So I can write it like plus 5 minus 2, right? So I have to decrement this particular value from my answer, and that would be my final solution. So in this case, it is 22 minus 2 plus 3, and that is 5, and so the final answer is going to be 70. So this was the whole approach for this particular problem. So I know that this sounds a little bit complex, but let me just quickly go through it once again so that it is much clear to you. So let me just remove all of this first. So what I am saying is, I am saying that if each of the arrays is allowed to give some values, that means if this particular array gives, the contribution will be 2. If this particular array gives, the contribution will be 2. If this particular array gives, the contribution will be 7. So now at least one of the arrays will have to act as the receiving arrays. Now if this array is the receiving array, first of all I would want to neutralize the contribution made by this particular array, right? So I want to subtract 2 from my final answer. Now if this is the receiving array, this is also going to receive the minimum value among all the other values. So it is going to receive 2 as well, right? So instead of this 5, the value contributed by this particular array is going to be 2. So this, the difference that has been created is 5 minus 2, right? And I wanted to remove 2 as well. So this is the total value that I want to decrement, right? And I can do this for all the arrays and find the minimum value like this among all of these values and decrement that particular minimum value from my answer. So let me just show you the final code and it will be much more clear to you. So you see what I've done is I've created a vector or double dimensional vector of size n. So I've also created a vector of pairs called increment. So actually the way I was implementing this particular problem earlier was a bit different. That is why I created this, but in my latest implementation, this whole vector is not actually required. You will see in a while why. Right. So what I am doing is I am just traversing through all the n vectors. I am taking the size of the vector and creating a temporary vector of size x. Right. Now I am sorting all the values and setting v of is equals to t. Now I am just adding this value to my increment vector. So you can just safely ignore this particular part. And what I am doing is I am just adding my answer plus is equals to v of I0. So this is going to be my smallest element in that particular array. Now I can also set my minimum as minimum of nin comma v of I0. Now I want to find the value that I can decrement by choosing one of the arrays as the receiving array. So I initialize this value with infinity and I am just going to all the values. So I am setting decrement as minimum of decrement comma. So this is going to be the smallest value in my current array minus nin, as I have already explained in the examples, that this is the value that is going to change, or this is the value that is going to be decremented, right? Now I already counted its contribution in this particular array, so I need to subtract it also. That is why I am adding this particular value to the DEC variable, right? So actually you don't need to write or use this increment array. You can now directly write v of I1 minus v of I0, right? That is going to give you the same value because that is what I'm calculating here, v of I1 minus v of I0, right? So you can do the same thing here. Now I just add this contribution to my answer as well. So basically what I'm trying to do is I'm just trying to add all of the contributions, and if one of them was the receiving array, I'm just going to remove its contribution while using this DEC variable. So at the end I can just decrement this value from my answer and just print my answer variable. So this was all about the second problem. Now coming on to the third problem. So I would say that this particular problem was a pure guess on my end. I still don't have a very clear explanation to why this approach works, but I'll try to explain you my intuition behind why I did it this way only. The problem defines the cost of a permutation P of length n, right? So the cost of the permutation P is going to be summation of the values pi into I, and among all such values, whichever of them is the maximum, you have to decrement it from your summation. So this is what the question says. Now what you have to do is you have to find the maximum cost of a permutation of the given size n, right? So this is the whole problem, and now let us discuss what is the intuition behind this particular problem. So let's say if you have an array 1, 2, 3, 4, right? So this is the initial permutation, right? Now the maximum value is obviously 4 into 4, right? So until and unless you don't change the maximum value, your answer is not going to change. So how can you try to change the maximum value? One way of changing the maximum value is doing something like this: 1, 2, 4, 3, and this has also been shown in the sample test case. So now if you have this particular case, you will realize that it is going to give you the best answer. But how did it change my best answer? You see, I shifted my maximum from this particular position to a different position on the left, right? So initially the maximum was 16, now the maximum is going to become 12. Again I can try to shift my maximum to the left, and in this case my maximum is going to reduce even further. So it can be like this, right? So now my maximum has become 9, which is 3 into 3. So essentially what I am doing is I am writing the initial elements, let's say 1, 2, 3, and I am writing the last element, and then writing all the other elements in the reverse order. So this way what will happen, my maximum is going to get reduced every time I move my max element to the left. So the idea is very simple. Why this is happening? So if I have the array elements or the indexes like this, if 7 was here, 7 into 7 was creating some huge value, then 7 into 6 will create even a smaller value, then 7 into 5 will create even a smaller value, and now 6 into 6 is going to take its place, right? Or the remaining elements is going to take its place, but that particular increment will never be equal to the maximum value of 7 into 7, right? That is always going to decrease, and also there is a limit to how much you can decrease your maximum element, because if you write the whole array in reverse order like this, you will see, let me just write it first, you will see the maximum is still 16 and you cannot reduce it to any value less than this. So why are we trying to reduce our maximum? What is happening if we have some value a minus b, we are trying to reduce this maximum, or in other words you can say we are trying to brute force through all the values of this maximum value of p. So by brute forcing through all the values, I am just going to take my best answer. So all you have to do is, first of all, you will have an initial permutation like this. You can choose any index and start writing your array elements in reverse order from that particular index. And now that for the new array that you have obtained, you can just find your answer and take the best among them. So let me show you my code, what I have done at the end. And I have initialized all the values from 1 to n in increasing order in the vector. Now I set my answer as 0 and I am just traversing through all the indexes. I set my temporary vector is equals to t, and starting from the ith index I am just going to reverse my vector t, right? Now I can initialize two variables, current and maximum, and I am just going to store my current sum in my current variable and my maximum value in my next variable, right? Now at the end what I can do is I can update my answer as maximum of answer comma current minus maximum. So this is going to be the final solution and you can print your answer variable, right? So this was all about problem C. Now let us have a look at problem D of this particular contest. So it is accepted as well. Now for this particular problem, they have made the problem statement a bit tricky, but the problem itself is very easy. It is not as difficult as it seems, and you will see in a while why. So basically they are saying that first of all there will be 3 segments, right? So this first value n is going to denote the number of segments. Now the first 2 values are going to denote the left and the right end of that particular segment, right? And if you are at any point in this particular segment 6 to 17, then you can teleport to any point in this particular segment 7 to 14, right? So this is what the question is saying. Let me just repeat this part again with the help of an example. So let's say we have a number line, right? And this is Li, this is Ri, and there will be 2 points inside it, Ai and Bi, right? Now if you are at any point inside this segment Li and Ri, then you can teleport to any point in this particular segment Ai to Bi, right? And there will be multiple such segments with L1R1, L2R2, L3R3 and so on. Now after all of these segments you have been given Q queries. Now each of the queries is going to give you a starting point called X. Now your task is to find the maximum distance you can travel when you are starting from the point X. What do we mean by maximum distance? You have to go to the most positive value that you can go with the starting point as X, right? So this is our whole problem. Now the very first observation when you see this problem should be that if you are at some point which is beyond Bi, right, then it is not very useful to use the teleportation power of this particular segment, right? Because even if I use the teleportation power, I would go to the maximum index Bi only, right? And if I am already at a greater index than Bi, then it is not optimal to go back to Bi, right? So I know that if I am already beyond Bi, then it is obviously not optimal to use the power of this particular segment, right? So one case that was going through my mind was, let's say if I have some other segment, can there be a case where after using the power of this particular segment, let's say this was point X and I try to go from X to Bi and then I use some other segment to go beyond X. Is this possible or not, right? Because if this is possible, then our problem would actually become quite complex, right? So this was the most important part, or this was the most important observation that you needed to make in this particular problem, that if I am at a point X like this, is it possible for me to go back to any point between Ai and Bi and then use some other segment to finally go beyond X, right? And you will realize that it is not at all possible, right? Why is it not possible? For example, if some segment is requiring you to be inside the range Ai to Bi, that means that particular segment will be ending at most at the position Bi, right? Say this is Rj, right? So if this segment is itself ending Rj, by using its teleportation power, you cannot go to any point beyond Rj. So with the help of this, we finally conclude, or we finally prove our point, right? So this is very important in greedy problems, proving your own point, right? So with the help of this particular observation, we prove our own point that if we are already at a point X which is beyond the Bi or the teleportation range of the current segment, then it is always optimal to not use the teleportation power of the current segment. So this part is very clear. So now for each of the segments, if I am given 4 values Li, Ri, Ai, Bi, only 2 of those values are important to me, and that are Li and Bi. Because if I am at any point beyond Li, I will always be able to go to the point Bi, right? And if I am at a point beyond Bi, then obviously it is not optimal to use the power of this particular segment at all, right? So let me just repeat this part again. If I am at any point beyond Li, right, then I can always go to Bi. That means if I am in this particular range, then I can always go to Bi, right? But if I am already beyond Bi, right, then it is always optimal to not use the power of this particular range and remain at a place where I am, right? So only Li and Bi are important to us, right? Now we will have multiple such values L1 B1, L2 B2, L3 B3 and so on, right? Let me just also write L4 B4. So now what happens? Let us discuss some cases. Now what happens? Let's say some L3 is equals to 3 and B3 is equals to, let me just write it, L3 is equals to 3 and B3 is equals to 10, right? And L4 is equals to 5 and B4 is equals to 8, right? So if I am beyond any point 3, then I can always go to point 10. But if I am beyond any point 5, then I am only able to go up to 8. Is this fair? No, because I can always use the power of this particular segment to go to the point 10, right? So what I'll try to do is, I'll try to update this particular value with 10 as well, right? So from here, I get the idea that I have to update my b of I as maximum of b of I comma b of I minus 1. Let me just repeat this part again. So if this was 8 and if I am beyond any point 3, I can always go up to point 10. But here I am saying that if I am beyond any point 5, I can only go up to 8. Right? This is not optimal. Why would I only go up to 8 if I always can go up to 10 using the power of this particular segment? Right? So I will also update this particular value to 10. From here I know I can create a forward for loop where I can update every value b of I as maximum of b of I comma b of I minus 1. So let's say some other example now. So let's say again L3 is starting at 3, L4 is starting at 5. Right? Now B3, let's say it is equals to 6 and B4 is equals to 10. Right? So that means if I am at any point beyond index 3, I can always go up to 0.6. Right? So let's say I was initially at 4. Now I can jump to 0.6. Now this condition is also satisfied. Right? If I am beyond 6, then obviously I am also beyond 0.5. Right? So that means if from 3 I can go to 6, then from 6 I can go to 10, then I can also say that from 3 itself I can go to 10. So again, if my b of I is greater than or equals to a of I plus 1, then I can update my b of I as maximum of b of I comma b of I plus 1. Right? So these are the two things, or these are the two changes that you will have to make to this particular array containing Li and Bi. Once you have made all of these changes, now when you get any point x, you can try to find this particular point x from these L's. So what were we storing in these pairs? We were storing the information that if I am beyond any point Li, then I can always go up to point Bi, right? So now I can find the maximum Li such that it is less than equals to x, right? Because if I can go up to beyond that point, then I will obviously be able to go up to the corresponding Bi, right? So now I can apply binary search on this final part to find the maximum value of Li such that it is less than equals to x, right? And if let's say my answer is L4, right, and let's say B4 is less than x, then I can obviously take the maximum of B4 comma x, because I can always try not to choose any superpower and I can always choose not to teleport and be at my current index x only, right? So this was all about this particular problem. Now let us have a look at the code. So you see what I've done here is I created a vector of pairs and this is v of size n. Now I'm taking all the values as input, but I'm only storing these two values, the Li and Bi, right? So it is stored in a and d respectively. So v of I dot first is equal to a and v of I dot second is equal to d. Now I'm going to sort all the values of v according to this starting Li, right? Now for the two for loops that I just discussed, now for the first for loop, this is going to be a forward for loop. I am going to set v of I dot second is equals to maximum of v of I dot second, v of I minus 1 dot second, right? The next one is a reverse for loop, for which I am going to check if v of I dot second is greater than or equals to v of I plus 1 dot first, then I am going to update my v of I dot second is equals to v of I plus 1 dot second, right? Now at the end, what I can do is I can just go through all the queries, and if v of 0 is itself greater than x, that means I cannot use even the first segment. So that is why I can just directly print x and continue. Now I know that I can always use the first segment, so I am using an invariance technique here. I know that I can always use the 0th segment. I know I can never use the nth segment because there will never exist n, right? The segments are only up to n minus 1, from 0 to n minus 1. So I know that low is always going to be true and high is always going to be false. Now I perform my binary search. If my v of mid dot first is less than equals to x, I set my low as mid, otherwise I set my high as mid, and now I can print the maximum of V of load at second, that is the B of I for the corresponding Li, and take its maximum with the value of x, right. So whichever of them is the maximum will be my answer, and after all the answer has been printed, I can just print a new line. So this would be the solution for the fourth problem. I hope that you guys were able to understand the solutions. If you guys did, consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So I see a lot of people who watch these videos have not subscribed yet. In case you're one of them, then definitely consider subscribing. It's always free of cost, and you can always unsubscribe if you don't find the videos interesting later. So share this channel with your friends, and till the next video drops, keep coding, stay safe, bye bye.